exercise we did last time, as usual. So I asked you to do inequality with absolute value of x less than 5. It was pretty similar to the quiz that we had the previous time. It was equation with absolute value compared with 5. So now it's inequality. So to solve this, I will place positive and negative 5s on my number line. That's the case when absolute value was equal to number 5. And then the solution will be right in between. In other words, x should be from minus to plus 5. So you could write solution with inequalities, or some people said it's from negative to positive 5 using this interval notation. They put in parentheses. So it's the same thing in both cases. So if you have absolute value which is smaller, then you are in between. Let me try one that has greater, like exercise number 67 here, with absolute value actually greater than or equal to, for a change. So 2 minus 3x inside the absolute value bars is going to be greater than or equal to number 8. Okay, so looks like we're going to be also placing our expression in between of two numbers. One of them is positive, the other is negative 8. So in between of those, we have now whatever sits inside the absolute values, right? So this portion, which is 2 minus 3x. So I have to now find what x is. So if I, in between minus 8 and plus 8, then we're going to need to little by little pull out our number x. So I'm going to subtract the 2 everywhere like that. That'd be my first step. And then left side will have negative 10. Now the middle part is minus 3x only. And on the other side, it's going to be 6. So now I'm going to be dividing by negative 3. Right? So when I do this, my inequality flips, because when we divide by negative, we're always going to reverse our inequality symbols. So once I done this, then we get a fraction with 10/3 on one side, and x is in between, and negative 2 is on the other side. So you got the answer, and I guess that's good enough to leave the answer with inequalities. So that's what I have for the case when we did 67, but notice that I wasn't very careful, because the way I solved it is if it was less than or equal, right? Less than or equal. So what happens if it's a greater than or equal? Well, for the greater, I have to be on the outside, right? And what's going to change? Well, I guess just this inequalities will bring me to the outside. So for actual 67, the answer has to be not in between, but on the outside, right? So it will be x instead of, let me write it again, 10/3 is less than or equal. Now this is going to be not less than, but greater than or equal. So this means that x is going to be from 10/3 to the other side, right? To the left. And analogously with the other piece, instead of x as being greater than or equal to negative 2, so now we not using greater than or equal, but the other direction. less than or equal. So that will be -2 someplace here to the left, and we have to put on the outside. The point of story, instead of being in between, we're on the outside if inequalities reverse their direction. So you can write the answer from -infinity to -2. And then -2 has to be included. So I need to be careful. I put a bracket, right? Equal sign. Oops, put a bracket. And then from the other side, 10/3, or people say 3 1/3, or 10/3, same thing, to positive infinity. So that's our other side of solution for this inequality. So once you have solved inequality, I guess interval notation is the most popular, so you have it there. So that's place to watch out. But anyways, when it's smaller, it's always in between. When it's greater, it's always on the outside. That is the message. So we spent already 2 class meetings with these absolute values, and I guess that's plenty of time. So we can see what else here. And we're actually going to move to the next chapter, because 2 inequality solutions is a little bit too much. So we're doing it in the next class usually. So what I do is I move to chapter 5. So it turns out from chapter 4, first 2 sections is what we care about now, and then we're going to get to the next chapter, to chapter 5, and that chapter starts a nice story of so-called polynomials that you already probably very familiar with, like 2x cubed, for example, or 2x power of 4 plus 5. So polynomials have whole powers of x. So let me get some room and start talking about chapter 5. That's what we're going to be dealing with for a while. And I don't intend to skip much stuff in that chapter because it deals with so-called polynomials. And those are just functions that we already saw a number of times in the other classes of math. So they have powers of x cubed, x squared, numbers multiplied, divided, added, or subtracted to those. So nothing really new, but the word polynomials. That's the only thing that they introduce us with. And then we're going to do various operations on them: add, subtract, multiply, even divide. And also we're going to factor those. So in the section 5.1, they talking about the polynomials and what they are and what they're not. For example, when you have something like a cube root of x, it's not a polynomial. Or if you have a power of 1/2, which is a square root of x, that's not a polynomial. And if x is raised to the negative power, it's also not a polynomial. So you want to just whole powers of x. That's the idea. Well, anyways, let's start with a practice exercises. And the main idea here is to find so-called degree of polynomial, or the largest power. So if I have exercise number 31, then here we have negative x to the power of 7, actually -5 times x to the power of 7. So people say that degree of this polynomial, which is actually the largest power, is going to be 7. How about that? It's not surprising. That's degree, the largest power. So if I'm looking at exercise number 35, in that case, my largest power here is going to be 2, right? Because we're dealing here with a 3x raised to the power of 2. So that's going to be our degree. So degree is So largest power of polynomial is what we're really dealing with when trying to find so-called degree. Well, how about exercise number 38 here with powers of polynomials such as x squared y to the fourth minus y to the 10th. I see. Looks like the largest power I see here is 10 because that's my indeed the largest from powers that we encounter here. And indeed, that's going to be my degree. Please notice that degree for the first term will deal with actual sum of powers, which is 2 plus 4, which is 6. And the 10 is still larger. So it turns out when you are going to have two variables in a term, x and y in this case, then you add the powers and get that way calculated your degree of polynomial. So that's the greatest from those powers that you have for each term. So using this idea, I can try problem number 39 to see what degree of that polynomial is in exercise 39. So here we have 4x squared times y to the power of 3. That's my first piece. And then we subtract 5 y to the power of 3 z power of 6. 5 y power of 3. There is also z, but there is w to the power of 6. Okay, this is better. So I care about the powers, and z is raised to the power of 1. So it looks like for the first term, we have 2 powers, 2 and 3, so their sum is 5. But for the second term, I have powers 3 here, 1, because it's just a z, so we say power is 1. And finally, 6. So when I add these 3 numbers, I get 10. So this is the largest power of terms that I have. That's why I declare degree of this polynomial equal to 10. So the largest power is what we care, degree. So we have polynomial story started, and what else is in here? Well, the other popular part is just plugging the numbers in, and that's what we already did lots of times before. So if I try exercise number 45, I can do one of those. I think this is something we always do whenever we have various functions. So if here I have function, instead of f of x, I call it as p of x. They just want to state it's a polynomial function, but it's still a function. So it's 2x squared plus x and plus 2. So if I have this kind of polynomial, then to find p of 0, I just have to replace my letter x with number 0, right? So I get a 2 times 0 squared plus 0 and plus 2. And this is just a 2, just a last term, because these disappear, right? Times 0 means 0. So it's just the introduction into the story. So I'd like to touch another section, because looks like sections here are pretty, I guess, standard and familiar, that you probably already numerously encountered. Like in the next section, they say collect like terms. And in the practice of exercises, I think these are nice sections because they have very nice and compact little exercises. And I hope that things like appear in the problem number 23 are pretty familiar. So when you have to add 9 y's with 7 of those y's, then the result will be 16 y's, because all you do is just add 9 and 7, and this y terms called like terms. So you get this terms with the same letter part, and that's why you add numeric parts, and that's about it. So how about if I try one more here? How about if I try exercise number 31? If you want to add the two polynomials. Well, first of all, I can write them without parentheses. So 5a plus 8 will be added with another one, which is 2a plus 3. Okay. So the like terms will have letter A in them. So this be 7a, and then 8 and 3 will be 11. So just add numbers separately and then letter terms separately. It's not very surprising. Now, what if they ask you to subtract those, like in exercise number 43, for example? Well, then you're gonna subtract them, right? So add or subtract, those are our favorite things. And here's 5t plus 7, the first term. And then when I start to subtract, I want to make sure that I change signs. So I kind of distribute this minus. So you're gonna get 3t with a minus sign, and then minus 6. And then we can again get those like terms put together. So 5 and 3, I subtract and get 2 t's. And analogously with numbers, 7 minus 6 is 1, so it's plus 1, just like that. So we have the way to do problems with adding on subtracting. And I hope it's something that you're already kind of familiar with. So I just want to do one more exercise in this section that should be good enough. So how about problem 51 that has some numbers in front of the parentheses? Let me copy this thing the way it's supposed to be. So 7 times x plus 1 in the parentheses. And then you have to also put a -4 in front of the other parentheses with x plus 4. Well, here we always distribute because parentheses have priority, right? So we need to take care of this parentheses. People say we need to distribute those numbers 7. So it'll be 7 times x, and 7 times 1 is just plus 7. And the -4, so it'll be -4 times x, and -4 times 4 is -16. Okay, so now I need to get those like terms to put together as usual. So the like terms will be terms with letter x. So this is 3x. And then 7 minus 16 is going to be -9. And this is it. So 3x minus 9 is the answer. So it looks like we just add numbers or subtract them, and that's about it. So maybe I can ask you to do a little problem analogous to what we just did in the previous section in 5.1 to find a degree. So let me do one more here to make you recall what we did with degrees. So if I look at the polynomial, let's say in the exercise number 41. So what is the degree of that polynomial? Well, I think it's largest power here, right? And it's 4. Right? So degree of polynomial is the largest power that you can find here, and degree is number 4. So largest power. So how about a quiz for you? An exercise number 42. Can you tell me what degree of polynomial is? So again, find degree. Don't do problem 42, actually. It's actually done down below, but I just care about degree. Find degree of polynomial in exercise number 42. So usual story. Please put the answer in the Zoom chat for me, but only to my name. Don't send it to the whole class. Just don't hurry. You got plenty of time, so don't hurry. So select only my name and put the answer. Tell me what degree in exercise 42 polynomial is. Find degree in number 42. That's our little quiz for today. Degree or the largest power, right? The largest power of polynomial in exercise 42. What is that?